Integration on the y-axis. Sometimes it is more convenient or even necessary to write x as a function of y and integrate on the y-axis. Definition: if x equals g of y and x equals h of y are curves where g and h are continuous on c equal to or less than y equal to or less than d with g of y equal to or greater than h of y, then the graph of g lies to the right of h and the area between them on the closed interval from c to d is given as the integral from c to d of g of y minus h of y dy. Example: calculate the area enclosed by x plus y squared equals 10 and the quantity y minus 2 squared minus x equals 0. This problem does not give the bounds of integration, so we'll need to find them. Let's first sketch the graphs of these two equations for a visual of the area of the region. The graph of y minus 2 quantity squared minus x equals 0 is a parabola that opens to the right with a vertex at 0, 2. The graph of x plus y squared equals 10 is also a parabola, but it opens to the left with a vertex of 10, 0. The graphs appear to intersect at 2 points. We'll integrate with respect to y, so to do this, we'll first isolate x in both equations. For the first one, we'll get x equals 10 minus y squared, and for the second equation, solving for x, we'll get x equals the quantity y minus 2 squared. Now we're going to solve for points of intersection, the y values. Setting the x's equal to each other, we'll get 10 minus y squared equals the quantity y minus 2 squared. Now we need to square the y minus 2. This equation becomes 10 minus y squared equals y squared minus 4y plus 4. We'll set that equation to 0. Then 0 equals, adding the y squared, 2y squared, minus 4y, and then 4 minus 10 would give us minus 6. Let's factor that. 0 equals 2 times the quantity y minus 3 times the quantity y plus 1. The graphs intersect at y equals negative 1 and y equals 3. Area enclosed by these two equations is shaded as shown. We write the integral with the rightmost equation minus the leftmost equation. So we will have the integral with respect to y from minus 1 to 3 of 10 minus y squared minus the quantity y minus 2 squared dy, which will lead to the integral from negative 1 to 3 of 10 minus y squared minus, then we've got y minus 2 squared, which would be y squared minus 4y plus 4 dy. Distributing the negative and combining like terms, the integral becomes negative 1 to 3 of the quantity negative 2y squared plus 4y plus 6 dy. Let's find the integral of each of the terms. The integral of negative 2y squared gives us negative 2/3 y cubed plus the integral of y is 2y squared plus the integral of 6 is 6y, and we evaluate that from negative 1 to 3. Putting in a 3 every place we had a y. In the first set of brackets, 2/3. 3 cubed plus 2 times 3 squared plus 6 times 3. Then we subtract. 2/3, where the y was, put in -1 cubed plus 2 times -1 squared plus 6 times -1. Then computing the arithmetic in the brackets, the result is 64/3.